Okay, so what we're going to do here is we're going to kind of go through this little thing here for distance and displacement. So distance and displacement is different from average speed, right? Or distance and displacement are different from each other. They have some similarities, but they are different. And then average speed and average velocity, again, similar but different. There are key distinctions. So an object's position on a treasure map can be marked with the letter X. There is a difference between how far an object has traveled and its change in position. So how far is distance? And again, we measured, all right, or the symbol for distance is lowercase d. This is the total distance traveled, like the odometer reading on a car. It's always positive, it's never negative. All right, and it's always positive no matter what, even if you turn around. So to find average speed is like the total trip. All right, that's always going to be the total distance traveled divided by the total time. Again, I've added the magic triangle in here, so if you're looking for just a singular speed, cover up S. Whatever's left over is d over t, so d divided by t. That is how you use the triangle. If you're looking for distance, you cover up distance. If they're next to each other, it's speed times time. And if you're looking for time, it is d over s, or d divided by s. Now, displacement is the change in position, how far you are from where you started. So change in position is known as displacement. All right, we use delta x to represent displacement. Now, to figure out delta x, we use this. All right, basically position 1 minus position 2, or how I use it is x subscript f minus x subscript I, and that stands for x's position, so it f subscript f x, right? That is your final position, so you can write that in, minus your initial position. Right, so your ending point and your starting point. Now, it can be different. If it's for an entire trip, that's a little bit easier. If it's for a specific line segment, all right, that is one of them as well. So it is going to be the difference between your starting and end point. Displacement can be negative. So if we're looking at a starting point and we move to the right, we would say that the right is going to be positive. If we end up to the left of our starting point, we could say that's negative. Or forward is positive, and backwards, if we finish backwards from where we started, that can be a negative number as well. And so that equation here, if we throw it into the triangle, velocity is delta x, which is displacement, divided by time. If you're looking for displacement, and you know what the velocity and time are, you multiply velocity times time. If you're looking for time and you have displacement and velocity, if you cover up t, what's left over? Delta x divided by v. Now let's look at our first graph. This is a position versus time graph. Guys, pick your heads up, please. So in this one, time is going to be on the x-axis. All right, so 0 here means we're at 0 time. That's the start of our trip or whatever. And the end time is pretty much, for the most part, when we end. Now, this is our position. So we can move forward, we can move backwards, and then we can not move. Those are kind of basically like what you're going to read on these kinds of things. So how I would suggest doing this is break down each individual line segment. So first line segment, this guy, right? Where are you starting? So how do I know? I go to 0, I go up until I hit the line. Where, right? And here's at that little dot. Now go all the way to the y-axis. Go all the way to the left. Where are you? What number? Say it. 2. Okay, so right here I'm at 2. Now at the end of this line segment, all right, which would be right there at this dot, go across, and now where am I? At what number? 4. So I went from 2 to 4. So how far did I move in total? If you went from 2 to 4, you moved a total distance of 2 meters. Good. So I'm going to write that there above that line segment. Now if we look at the next one, 4, right? This is the next line segment from here to here, right? How do I know which line segment's which? Basically, does it change slope or does it change like direction? So from here at 4 seconds, I start here, go across them at position 4, and then at 12 seconds I go up, go across, guess where I'm at? Position 4. So did I ever change my position? No. I didn't move forward, I didn't move backwards. So for here we're going to write 0. I did not move. So a horizontal line on a position time graph means you didn't move. You didn't move forward or backwards. You didn't move left or right. And then this last line segment, starting at 12 seconds, right? We go here. We are starting where? At 4. And at the end of the line segment, which is here, we finished at 8. So we went from 4 to 8. So how far did we actually move? 4 meters. Good. So to figure out the distance traveled, add all the line segments up. 2 plus 0 plus 4. Obviously, you don't need to write 0, but I'm just showing you so you don't think it just disappears. And that is 6 meters. That's your distance. Now, your average speed is the total distance traveled divided by the total time. So speed is equal to distance divided by time. Your distance traveled was, we just calculated that to be 6. And how long were we moving for? So where do I find that? Go to the x-axis. We went from 0 to how much time? 16. So we had 6 meters, and you're going to divide that by 16 seconds. And that comes out to be 0.375, and the unit will be meters per second. All right, that seems pretty easy. Well, what about displacement? Well, when they're asking displacement for the whole thing, it's actually pretty simple, right? What was our equation, or how do we figure out the displacement? The final position minus the initial position. Delta x, so your displacement, right? Displacement is just another word for overall change in position. How far are you from where you started? So we do xf minus xi. So xf basically means where did you end up, your final spot. So go to the end of the time that you moved, which is 16 seconds. Go up till you hit your slope or line. Now go across. What position am I at? 8. So 8 would be my final position. And where did I start at? So where is my starting time? 0. And go up until I hit my slope. Right here. And then go to the left. And what position am I at here? 2. 8 minus 2. How much is that? 6 meters. Now, it is a positive number, so my direction is indicated here by the positive, it being a positive 6. Now, velocity, we have the equation here. If I cover up v in the triangle, v is equal to delta x divided by t. So I'm going to write v equals delta x divided by t. Now, I'm taking what I just solved for the displacement as 6. All right, it's positive 6. And I'm dividing it by how long were you moving for in total for this? We started at 0 seconds. We went all the way to 16. So my time is still 16. And when I happen to divide this out, this also comes out to be 0.375 meters per second. Second graph done very, very similarly. I'm going to just do this one, all right, here. Distance traveled. We started here at 0 seconds. We started at position 5. This is the end of the first line segment. We did not change our position, so this is 0. We went from 5 to the end of this line segment, which is if we get to here and go across, we're at 1. So 5 minus 1 means I moved 4 meters. And then I'm here at the start of this line segment. I'm starting at 1. And I end it here, which is at 1. So did I ever change my position? No, so that's 0. So what is my total distance traveled? 0 plus 4 plus 0, which is just 4 meters. How long were you moving for? How many seconds was this whole thing? 8 seconds. So speed is distance divided by time. So 4 divided by 8, which would be 0.5 meters per second, because our unit for distance was meters and our unit for time was seconds. Last one, and then we're done for the day. Displacement delta x, which is your final spot minus your initial spot. All right, when they want it for the whole trip. So pretty much go to where you finished. So we finished at 8 seconds. So I go to 8 seconds, go up until I hit my slope or line, go all the way to the left. Where would I be? 1. So xf would be 1. We're going to bring down the negative sign. xi is your starting position. So go to 0 and go up. And who said it? Yes, it is 5, right? That's the starting time. So we go up until we hit our line, which is at 5. So what is 1 minus 5? Negative 4. So that is our displacement. Can we have a negative displacement? Change in position. It can be negative. So think about it as basically like negative is like to the left of where you started. All right, positive number would be to the right. All right, and then so the average velocity, v is equal to delta x divided by t. So you will have negative 4 divided by 8 seconds, and that will give us negative 0.5 meters per second as our velocity.